Sometime in 2026, the most powerful AI systems on Earth quietly crossed a threshold that nobody announced and almost nobody noticed. They had consumed, in practical terms, every meaningful piece of text that human beings had ever written and digitized. Every book, every forum post, every scientific paper, every court transcript, every news article published since the invention of the internet. Researchers at Epoch AI estimated that this moment, what they privately called peak data, would arrive between 2024 and 2026. The companies building these systems knew. They just didn't say anything publicly because the implications are genuinely frightening. Here is why you should care right now. The entire global AI industry is built on one foundational assumption, that there will always be more high-quality data to train on. More data means smarter models. Smarter models mean more revenue. NVIDIA's market cap crossed $3 trillion largely because the world believed this pipeline was infinite. It is not. When Anthropic, Google DeepMind, and OpenAI all began reporting diminishing returns on their largest models in late 2024 and throughout 2025, analysts initially blamed inefficient architectures. But several researchers who left those companies told the same story in different words. The ceiling they were hitting was not compute, and it was not architecture. It was the data itself. If scaling laws break down because the training resource has been exhausted, every forecast about AI capability growth, every investment thesis, every government AI strategy, every industry disruption timeline is built on a foundation that no longer holds. The economic consequences alone run into the trillions. But the deeper consequence is stranger and harder to see. To understand what is actually happening, you need to understand how large language models learned to be impressive in the first place. Starting around 2017, researchers discovered that if you fed a neural network enough text and asked it to predict the next word over and over again, billions of times, across hundreds of billions of examples, something remarkable emerged. The model didn't just learn grammar. It absorbed the internal structure of human reasoning. It learned how arguments are built, how analogies work, how a medical textbook differs from a legal brief. The training corpus for GPT-3, released in 2020, was roughly 45 terabytes of text. GPT-4's training set was estimated at over a petabyte. Think of it this way. If GPT-3's data were printed in standard paperback novels, you'd fill a library. GPT-4's would fill every library in the United States, twice over. Each jump in scale produced a jump in capability that seemed almost magical. But this process required one thing above all else: genuine human-generated text, written by people who actually understood what they were writing about. And that resource, it turns out, has a hard ceiling. Here is the first thing most people don't know. The internet is not as large as it feels. The Common Crawl dataset, which most major AI labs use as a primary source, contains roughly 5 billion web pages. That sounds enormous. But when you filter for quality, removing spam, removing duplicate content, removing machine-generated text, removing pages with no semantic value, the usable fraction collapses dramatically. Researchers at the University of Washington found in 2024 that less than 15% of publicly crawled web content meets the quality threshold needed for effective model training. That means the real training internet is closer to 750 million high-quality documents. And those documents are not growing fast enough. Human beings produce high-quality long-form writing at a pace that AI consumption has now outrun by a factor of roughly 10 to 1. Epoch AI's models projected that at the rate frontier models were scaling, the high-quality English-language text supply would be functionally exhausted by late 2025 at the current consumption trajectory. The labs know this, which is why, behind closed doors, the race is not to build bigger models anymore. It is to find an entirely different fuel source before the tank hits empty and the public notices. The second revelation is the one that truly reframes everything, because the obvious solution made the problem worse. If you run out of human data, you might think, train AI on AI-generated data. Let the model produce its own training material and feed it back in. Several labs tried versions of this approach beginning in 2023. The results were deeply alarming. Researchers at Oxford and MIT independently documented a phenomenon they called model collapse. When a model trains on its own outputs, even partially, the distribution of its knowledge begins to narrow. Rare but important concepts, the long tail of human knowledge, get progressively squeezed out. By the third or fourth generation of self-training, models began producing text that was fluent but catastrophically shallow. Imagine photocopying a photocopy 15 times. Each generation loses fidelity. The words remain, but the meaning degrades. In quantitative terms, one MIT study found that after 5 generations of synthetic self-training, model performance on complex reasoning benchmarks dropped by 31%, while performance on simple tasks held steady. This is the trap. AI-generated text looks like data. It has sentences and paragraphs and structure. But it lacks the one thing that made human text so valuable: the residue of genuine understanding, lived experience, and original thought that comes from a mind that actually exists in the world. So how does a language model actually use data, and why does the source matter so much at the mechanical level? Training works through a process called gradient descent. The model makes a prediction, the next word in a sentence, and measures how wrong it was. It then adjusts millions of internal numerical weights, very slightly, to make a better prediction next time. This happens billions of times across billions of examples. What the model is really doing is building a compressed statistical map of human thought. The diversity and depth of the source material determine the resolution of that map. Human text contains something researchers call epistemic texture, the fingerprints of genuine uncertainty, contradiction, revision, and discovery. A scientist's paper contains not just conclusions, but the shape of how a mind worked through a hard problem. A court transcript contains genuine conflict between perspectives. A personal essay contains the friction of real experience. Synthetic text, generated by a model that has no experiences and no genuine uncertainty, smooths all of that texture away. It produces confident-sounding sentences that map to nothing real. Training on it is like building a map from another map instead of from the actual terrain. Each copy drifts further from the territory. The complications do not stop at technical degradation. There are 2 other pressures converging that make this worse. The first is legal. In 2025, a federal court ruling in the United States affirmed that training AI models on copyrighted material without license constitutes infringement under certain conditions. The New York Times lawsuit against OpenAI, which reached partial settlement, established precedent that premium publishers could demand compensation or restriction. Overnight, a significant fraction of the highest quality training data, journalism, academic publishing, literary fiction, became legally contested territory. The second pressure is structural. As AI-generated content floods the public internet, the ratio of synthetic to human text shifts rapidly in the wrong direction. By 2026, some estimates suggest 30 to 40% of new publicly indexed text is machine-generated. The training corpus of the future will be increasingly contaminated with exactly the kind of shallow synthetic content that causes model collapse. These 2 forces together create a narrowing corridor. Less high-quality human data is legally accessible. More of the available data is AI-generated noise. The usable signal is shrinking from both ends simultaneously. What does this mean for you specifically? If you work in any field that touches software, content, marketing, research, or analysis, the AI tools you are depending on right now are approaching a capability plateau. The tools you have in 2026 may be close to the ceiling of what this generation of AI can do, not because engineers stopped trying, but because the training resource ran out. More concretely, companies that made hiring decisions based on AI handling certain functions may find those functions hitting hard limits sooner than projected. If you are betting your career transition on a specific AI capability arriving by 2027 or 2028, add uncertainty to that timeline. The labs will find workarounds. They are already pursuing reinforcement learning from human feedback and new synthetic data pipelines. But the easy gains from simply scaling up are over. Watch what OpenAI, Google DeepMind, and Anthropic announce about training methodology in the next 18 months. A sudden pivot away from scale is the signal that confirms what this video just told you. Here is the perspective worth holding on to. Every transformative technology in history has hit a resource wall and been forced to innovate around it. Steam engines hit the limits of hand-dug coal mines and invented mechanized drilling. The Green Revolution hit the limits of arable land and invented synthetic fertilizer. The data wall is not the end of AI progress. It is the end of